This video is about how to find the arc length of a smooth curve and how to find the area of the surface of revolution. Finding the arc length of the graph of y is equal to f of x over interval AB is given by this formula, integral from a to b, the square root of 1 plus f prime x squared dx. Or s is a lowercase s, integral from a to b, the square root of 1 plus dy over dx squared dx. Arc length, the graph of a function which is a function of y over interval CD is given by this formula. S is equal to integral from c to d, the square root of 1 plus g prime y squared dy. Let's example here, find the arc length of the graph of a function over the indicated interval. So here the y is the 3 over 2x to the 2/3, the interval is 1 to 8. So a is 1, b is 8. So first step is we find the dy over dx. So let's start with the y is equal to 3 halves x to 2/3. Power rule of differentiation. Apply this on y becomes dy over dx. We have 3 halves. We bring the power down to thirds, subtract 1 from the power. And now to subtract 1, we change 1 to 3 over 3. So now you can also cancel 2's with 2's, 3's with 3's. And this will simplify to x to the negative 1/3. Now we decide the formula for the arc length. But since y is equal to 3 over 2x to 2/3 is a function of x, so we use this formula s equal to a to b, integral from square root of 1 plus dy over dx squared dx. Now we substitute a1, b8 and dy over dx x to the minus 1/3 in this formula. S is equal to a to b square root of 1 plus dy over dx squared dx. So this becomes s equal to integral from 1 to 8, the square root of 1 plus x to the negative 1/3 dx. Now we just simplify this one by square the x to the negative 1/3 be x to the negative 2/3. So we have now integral from 1 to 8, the square root of 1 plus x to the negative 2/3. Okay, now we rewrite x to the negative 2/3. So using this formula, and we have now integral from 1 to 8, the square root of 1 plus 1 over x 2/3. Now we have to add these two and write as a single fraction. So here is the work 1 plus 1 over x 2/3. While LCD is x 2/3, we can change 1 to x 2/3 or x 2/3 and plus 1 over x 2/3. Now we write the x 2/3 once and we can add the numerators. So we change this to x 2/3 plus 1 over x 2/3. Now we break this radical into two radicals. And so we have an integral of 1 to 8, square root of x to the 2/3 plus 1 over x to the 2/3, the 1/2 becomes x to the 1/3, so x to the 1/3. Okay, so now to evaluate the integral, it looks like a fraction, so we can use substitution method. We cannot divide, we cannot simplify. So the only way you can do is substitution method. So we're going to see u is a more complex part of this one. I think we can use we can let u is equal to x to 2/3 plus 1. Now I find the differentials or differential. So u becomes du, and here we bring the power down 2/3, subtract 1, so x to 2/3 minus 1. The derivative of 1 is 0. And multiply with dx. Now we have to simplify. Looks like 2/3 minus 1 will be 2/3 minus 3/3, which would be negative 1/3. So you have now 2/3 x to the minus 1/3 dx. Let's rewrite as 2/3 1 over x to the 1/3. So this is the differential. Now let's rewrite our the integral for the arc length, which is 1 to 8, the square root of x 2/3 plus 1 over x to the 1/3 dx. So according to the differential, we can move the x to the 1/3 here and we multiply 2/3 here, and outside we divide or multiply with the reciprocal of 2/3, which is 3/2. Now we can make changes. So for this whole thing, this looks like is u du. So this whole thing we change to du, and this under the radical sign x to 2/3 plus 1 we set to u. So now we have an integral 3/2 1 to the 8 square root of u du. Now the problem here is that the variable is u, but these are x values, so we have to change also. We have to find the u values for these x values. So what formula should I use? This one, let form, this one. So we're going to see x is 8, we put 8 in this formula, x to 8 to the 2/3 plus 1. Now we simplify. 2/3 mean you first find the 8 to the 1/3 and square. So 8 to the 1/3 is like a cube root of 8, which is 2, and then square the 2 becomes 4. So it becomes 4 plus 1 equals to 5. Similarly, we put x equal to 1 in this formula and simplify. So it becomes 1 to 2/3 plus 1. Well, 1 to 2/3 is 1. So it becomes 1 plus 1 is 2. So now this integral becomes 3 over 2 integral of 1 to 5 the square root of u du. Okay, now we rewrite the square root of u in exponential form, so we can find the integral. So square root of u is u to the 1/2, and now we use this power rule. So we have now 3 over 2 u to the 1/2 plus 1 over 1/2 plus 1. Remember, 1/2 plus 1 is like a 1 and 1/2, which is 3/2. So you have now 3/2 u to the 3/2 over 3/2. Now division by 3/2 means multiply the reciprocal. So you have a 3/2 times 2/3 times u to the 3/2. 2 cancel with 2, 3 cancel with 3, and now I put 5 where the u is. So you have 5 to the 3/2, and then minus, put the 2 where u is to become 2 to the 3/2. So here we can break it down. 3/2 is like a 1 and 1/2. So you can break it down as a 5 and the square root of 5, and this is 2 and the square root of 2. So first put this answer in a Weber sign. If it takes, if it doesn't take, then you use the calculator and put this answer. Okay, the area of surface of revolution. When the graph of a continuous function y is equal to f of x on the interval ab is revolved about the x-axis, so you get this kind of solid. So the surface area of this solid is given by this formula 2 pi a to b y square root of 1 plus dy over dx square dx. But if you revolve this about x-axis, y-axis, then the formula changes to 2 pi a to b x the square root of 1 plus dy over dx square dx. The only difference is that here is a y and here is a x. That's the only difference. Otherwise, both formulas similar or same. So here is an example. We're going to write and evaluate the definite integral that represents the area of surface generated by revolving the curve on the indicated interval about the x-axis. So here is the curve, and this is the interval that we're going to revolve about the x-axis. So we start with the y is equal to 1/3 x cubed and find the dy over dx. Using the power rule, it becomes 1/3 3x squared. 3 cancels with 3, so dy over dx becomes x the second part. Okay, now the axis of revolution is x-axis. So the formula we're going to use 2 pi a to b y times square root of 1 plus dy over dx squared dx. Now we substitute a 0, which was given, b is 3, y is 1 over 3x cubed, and dy over dx we found the x squared. So the formula becomes 2 pi integral from 0 to 3 1/3 x cubed square root of 1 plus x squared squared. Well, simplify, and we can factor 1/3, so become 2 pi over 3 integral from 0 to 3 and become 1 plus square root of 1 plus x4, and we can move the x cube in the front. And now you can see this x cube is almost the derivative of 1 plus x4, so we can set or let u equal to 1 plus x to the 4, and differentiate, you can find the differential. So u change to du, differentiate this one, so it becomes 4x cubed dx. So, and also we can change the limits, values the limits. So when x is 3, we can put 3 in this formula, 1 to the 3/4, which becomes, I think, 82. And we put x 0 here and become 1. So now we change all this information in this integral. So this integral becomes 2 pi over 3 and the square root of 1 plus x4 times 4x cubed dx. So according to this, because of this, we have a 4x cubed and we have x cubed. So we multiply 4 here and divide by 4 here. So that's why we got 4x cubed dx and 4 here. Now we can change 1 plus x to the 4 is u, 4x cubed dx is du. And we replace the 3 with the 82 and the 0 by 1, and we have this interval s is equal to pi over 6, 1 to 82, square root of u du. Again, we can rewrite square root of u is u to the 1/2. So it becomes pi over 6 integral from 1 to 82 u to the 1/2. Using the power rule of integration, so you will have pi over 6 u to the 1/2 plus 1 or 1/2 plus 1. 1/2 plus 1 is 3/2, so you have pi over 6 u to the 3/2 over 3/2. Now 3/2 division means multiply with the reciprocal of 3/2, which is 2/3, so you have a 3/2. Now we substitute. We can simplify also. 2 divided into 6 is 3, 3 times 3 is 9, so it becomes pi over 9, u to the 3/2. Now we substitute 82 first. We have pi over 9, 82 to the 3/2 minus, substitute 1, 1 to the 3/2. 1 to 3/2 is 1. And again, it's 3/2 mean 1 and 1/2, so you have become 82 square root of 82 minus 1. Okay, so this is the answer, goes to November sign. But if it says, doesn't say it's not right, so you can put on the calculator around to decimal places and try this answer. That's the end of this video.